There's another important type of sequence that we need to talk about. And this type of sequence is what's called a bounded sequence. So let me show you the definitions that are pertinent here for bounded sequences. So a sequence A sub n is bounded from above if there's m such that A sub n is less than or equal to m for all n. And so what this is saying here is that this number m here is bigger than every single term of our sequence, bigger than or equal to every single term of our sequence. And so if we have this first case here, then we would call m we would call is an upper bound for our sequence. So just like we have bounded from above, we also have bounded from below. Sequence A sub n is bounded from below if there is some number p such that A sub n is greater than or equal to p for all n. Every single term of our sequence is at least as big as p is. And so p is a lower bound. For A sub n in the sequence, and in this case. And then finally, if our sequence is both bounded from above and bounded from below, we say that it is bounded. And sometimes if it's not bounded, we can say our sequence is unbounded. Let me just draw a picture or two about this. So, so just if I were to say, okay, here is, here is some, sequence. Well, maybe I can make it so that it looks like it's going up a lot more steeper here. This sequence would not be bounded from above if the terms keep going up and up and up to infinity, but it would be bounded from below. Like if I make this value here of p, every term of the sequence is at least p. What would a sequence that's both bounded from above and bounded below look like? Well, let's say here that, let me just kind of shift my axes a little bit. Let's say here is my lower bound. Let's say here is my upper bound. So I just have to draw a sequence so that none of the terms are smaller than p and none of the terms are bigger than m. So okay, here's my perfectly good bounded sequence. Every term falls between p and m. This is doing it with pictures. I can also give you a specific formula here. So for example, let's suppose that we have A sub n is equal to 3 minus 1 over n. So this is going to be bounded. Yeah, so BDD is my abbreviation for bounded sometimes. It's bounded from above by m is equal to 3, because every term of the sequence is 3 minus something positive. So the terms are always going to be less than 3. So 3 is an upper bound. It's bounded from below by, let's say, p is equal to 0. So the biggest thing that we can subtract off here, if n is equal to 1, we're subtracting off 1 over 1 is 1. So the terms here go like 2, 2.5, 2 and 2/3, 2 and 3/4. So p is equal to 0 is certainly a lower bound here. And so because we have both an upper bound and a lower bound, we can say that the sequence is bounded. If you want a picture of that, so if you want a picture of that, the first term would be like so like, let me kind of say here is like 2, here is 3. The first term is at 2, the next term is like at 2.5, 2 and 2/3, 2 and 3/4. And so those terms are all going to be less than 3. I mean, they are going to get closer and closer to 3. I don't know how much closer to 3 I can draw, and they're all going to be at least as big as 0. And I should point out that this kind of helps show a different fact, which is that upper and lower bounds are not unique. So 0 is certainly a lower bound here, but we could put the lower bound all the way up to like 2 here and still have it be a lower bound, or we could do anything negative down here. Those will all be lower bounds. So in general, you have some lower bound. Anything less than that will also be a lower bound. Here's an upper bound. Everything, 3 is an upper bound, 4, 5, 6. All of these up here will also be upper bounds as well. The point here is just that there is some upper bound, and so our sequence is bounded. Okay, so final thing I want to talk about in this video, how does boundedness play with convergent sequences? So, sequence converging is basically our most important property a sequence can have. How does this play? How does this new notion of having a bound sequence play with being bounded? And as it turns out, we have a nice theorem here that every single convergent sequence is bounded. If you want to write this out symbolically, let me get to my scribble tool. If the sequence A sub n converges, then A sub n is bounded. And so there's, there's a kind of formal proof from the book that I could go through. I don't think I really want to go through a formal proof, but just kind of show that, hey, if our sequence is getting closer and closer to some value, and it's converging to that value, if it's converging like to this value right here, well, it's going to be bounded. We can't get too far away from this. We can't get too far away from this. Think about what would happen, how would our sequence be unbounded if it's going way up or going way down? Well, it's going way up or going way down a finite number of times. We just extend our bounds, incorporate in all of that stuff. And if it's continually, it's infinitely often going way far away from where it's converging to, it's just not going to converge there. So every convergent sequence is bounded. So this is an important fact here. However, to kind of follow up on this discussion, it's important to note here that not every bounded sequence converges. So every convergent sequence is bounded, but not every bounded sequence converges. What's going on here? So consider the sequence A sub n is equal to -1 to the n. So the sequence just goes -1 + 1, -1 + 1, -1 + 1, ... And if I draw this on some axes here, the idea is we ping pong back and forth. And this definitely doesn't converge. Definitely doesn't converge, but hey, it's bounded. There's an upper bound, there's some lower bound that's bounded. So this is a bounded sequence that doesn't converge.